So you can view that log by clicking this button, and it shows you all the data that was sent across the UART and everything that the CPU executed. This is fragmented right now, obviously, because I started logging and I stopped logging and started and stopped. So, but it's really useful, especially if you're running the Kevtris's NES test ROM, because I have it set up so that if you click this button right here, you can configure the CPU to use the automatic feature of the NES test ROM, and I forget exactly what that does. I think it like starts it at a specific address or something, but I can't completely remember. But anyways, yeah. So one of the optimizations I want to do is right now that Pbe CPU logger is actually literally sending every single one of these ASCII characters, and that is terribly inefficient. You know, when I first wrote it, I was just doing it to see if it could be done. The more efficient way to do it, obviously, is to just send the raw binary data and then post-process it on my on my 64-bit, 3.2 gigahertz multi-core processor. That is the way to do it. And then I'm not saying that that's going to make the game playable as you're logging, but it'll certainly be a heck of a lot faster. But anyways, you can look through this. You can take this, and eventually I want to add a compare button, which will be able to compare the output to the NES test, the known valid NES test log. And I've actually already done that. I'm not going to do it now because one, I don't remember how to do it. But my emulator actually does match exactly. This output does match exactly to the official NES test output. So, and you can't save it right now. I just put that message in there as a placeholder. If you clear it, it does actually clear it, and it does actually free the memory in that emulator. What else? So this Ethernet test packet button. So this is what I'm going to show you earlier. This is what I mentioned earlier that I was going to show you. Whenever you push this button, this just tells the Pbe CPU logger to send a hello, the obligatory hello world or hello packet over UDP to the GUI, and it receives that packet. So that's just a test for me. It's a proof of concept that it can be done and that Qt can handle it, and that the QUDP socket interface works and everything. So the framework is all there, and like I said, I just got to flesh it out so that it actually does something useful. So the Pbe Lockstep button, I mentioned this in my previous video. I'm not going to click it now because so essentially normally what happens is Pbe lockstepping is enabled, and when you run the CPU logger, when it deasserts ready on the CPU, it'll also deassert ready on the, or not ready, but forget what pin I use. But I think it's a clock enable or something. But it'll keep when it freezes the CPU, it will freeze the PPU. And if you don't lockstep it, it messes up. Depending on the game, it messes up the graphics like crazy, and can actually cause the game to freeze for obvious reasons. It's actually pretty cool to watch because some of the games do some really, really weird stuff. But that's pretty much it for the Pbe CPU logger interface. I'm actually going to go ahead, before I show you the other UART mux, I'm going to load up Super Mario Brothers again. And so the third thing, and this one is really awesome. I like this one because when I'm play testing these games, I mean, some of these games are freaking hard, man. And I'm not the platformer that I used to be, so the Game Genie codes help out a lot. So with these Game Genie codes, essentially, so if you click this button, I recreated the circuitry for the original Game Genie, that little Game Genie attachment. This interface actually doesn't use that. I created my own custom Game Genie interface where I could have multiple codes, but I have two different Game Genie designs, the original one and then a custom one that I use. So what you can do in here, I actually have one of the Game Genie codes for Super Mario Brothers memorized. Actually, I have two of them memorized, I think. Let me see. APZLGG. I think that's right. So what this is doing is it'll light up green when the Game Genie code syntax is valid. It will actually go and check and make sure that, because Game Genie codes have a particular syntax, and this interface won't allow you to enable the code if it's not correct. So and for example, like 6-letter codes have a different syntax than 8-letter codes, etc. So this is a valid 6-letter code, but if I add 2 more characters to make it an 8-letter code, that's not going to work. And obviously there are no 7-letter codes, so that doesn't work. Just adding 2 more characters is not going to do it, because that's invalid. And it's invalid because, not that anybody really cares, but I think the most significant bit of the 3rd character in the code designates, if it's 1, if it's a logic high, then, or binary 1, then it's an 8-letter code. If it's low, then if it's binary 0, then it's a 6-letter code. And there's lots of other stuff, like some characters like literally don't exist in Game Genie codes, like Q, I think, maybe, I don't remember exactly. But anyways, if we do this and we say OK, this is going to send the codes over the UART, over the Game Genie port, logical port of the UART. So essentially there's one master UART interface, and then it disperses the commands to the proper port based on this, this protocol that I made up. So so if we say OK, I can demonstrate some of these. So SXI OPO is infinite lives, and then this one, the code 1, is I think it's like mega jump from standing still. So if I click OK, so yeah, so that's mega jump. So that's the APZLGG. Now if I kill myself, I'll still have 3 lives left. Okay, so now I can turn these off. I can turn just one of them. So for example, here I'm doing a mega jump right now. If I uncheck this box and say OK, then I'm back to normal jump. And we'll turn that back on and turn infinite lives off. Now I have mega jump again, but if I kill myself, I'm only going to have 2 lives left. And if I turn that back on and I turn the master enable off, that will disable any code regardless of whether it's checked or not. So if I say OK and the master enable is off, I have 1 life left, and also obviously I don't have the mega jump anymore. But as soon as I enter the master enable, say OK, then I've got the mega jump. See, if you're running, you don't get the mega jump. But actually, I'm just going to play this first level because I'm interested in how Camtasia does with the latency on this and see how good it looks. So I'm really just doing this out of my own curiosity. You can fast forward through this if you like. So that's it for that. I'm wondering, I think I'm pretty much done here, guys. So I showed you the, oh, another cool thing it was do, see, this is why I wrote myself notes. Another cool thing this does is if you load up, so codes are enabled right now, if you load up a new ROM, it will automatically disable the Game Genie codes, which is important because you don't want some like codes for Mario Brothers, messing with Bubble Bobble, because that could mess up the game pretty bad. So let's see here what else I want to go over. I'm also going to be. This is some fairly big news. Okay, so here's an example of an error. I'm not sure why this just happened. It might have happened because I loaded up the game too quickly, or something. But if there's an error in the CPU, I think EB, an error with a code B, is an illegal instruction. I think that just happened because I loaded up the ROM too quickly after the reset, because the reset takes like 2 or 3 seconds. So I'm gonna reload that and see if that fixes the problem. So some bigger news is I'm actually going to be moving this design to Alterra. So the game loaded fine. So that was what the problem was. It essentially started sending the data before the ROM upload interface was completely ready. So that's not a big deal. Eventually, I'll be able to interrogate the emulator. Same kind of stuff same kind of interface we used for fleshing out this panel on the right hand side. But I'll have the FPGA report a state of health, and it'll be able to show me or tell me. The GUI interface will be able to know when the CPU has come out of reset and is ready. So just another thing I had. So anyways, I'm going to be moving to Alterra simply because, well, one, I've never used Alterra before, and I think it would be interesting to do that. Two, I've got lots of reasons. Two, I mean, be honest, I am just completely and utterly, this is just my opinion, but I am just completely, utterly sick of the Xilinx synthesis tool. It is I'll just be honest, I'll be frank, it's a complete piece of garbage. I'm tired of the errors. I mean, there's things like, if you're a Verilog or an HDL designer and you're watching this, I mean, if you want to do something even remotely semi-intelligent with multi-dimensional arrays in Verilog or VHDL, forget it. I mean, and the other thing that makes it even worse is it'll say, okay, I'm synthesizing it and it all looks good, and then it'll make you a bit stream, and then your hardware won't actually work. It's a joke. It's a complete joke. I'm just so frustrated. I've had it. I'm done with XST. I won't use it at work anymore either. I'm actually using Simplify at work, which is pretty much the premier synthesis tool on planet Earth, I think. That's just my opinion, but the free version of Quartus, which is the Alterra development environment and synthesizer, I've heard lots of good things about that, and it actually has native support for System Verilog, even the free version, and I've heard that the System Verilog support is very, very good. So I'm really looking forward to that. Also, I got a Alterra development board, which I'm really looking forward to using. I'm looking forward to doing that, and I already tried porting over my code to Alterra, and I could not believe how easy it was. Like, Alterra provides this really, really nice document that essentially says, okay, if you're a Xilinx user and you're using such and so block RAM primitive, or you're using, such and so FIFO primitive or something like that, here are the equivalents in Alterra. Here are our equivalent FPGA primitives. So DCMs or PLLs, it tells you exactly what you need to do, and it even gives you the comparison of, okay, this is what our parameter or port is called, and this is the equivalent port or parameter for the Xilinx devices. And it is incredibly nice. I also really like using Alterra as a linting tool that I've just discovered, because Alterra Quartus is really, really picky about syntax. Like, it'll warn you on anything that it is even remotely not, exact Verilog perfect syntax, which I really, really like, because, I mean, one, it makes me a better programmer, and two, it makes the design better, and less prone to errors. So